Hey everyone, this is Mr. Abramovich, and we're going to talk about part one of your projectile pendulum lab. So, as you have already done, you figured out that there is a connection between how high you release this pendulum from and what its speed will be at its lowest point. So what we're doing here is we're going to try to test out the model you came up with by measuring the speed of the pendulum at the lowest point when we release it from different angles. So the angle will be our independent variable, and the speed at the bottom will be our dependent variable. And hopefully we'll be able to see how good our model is from that. So all we did here is we set up a photo gate to measure the speed at the bottom. You can see the little red lights blink. When this pendulum passes through, those red lights trigger. So I just collected a bunch of data, releasing it from different angles, letting it swing through, being careful, making sure to catch it on the other side so it doesn't swing back and give me numbers I don't want. Another thing to point out is I put a little tiny piece of tape here right in the middle of this pendulum. I can actually hold it a little closer. It's more visible. Not worth it? Okay, Mr. Graham is telling me no. The mark here is because when we measure the height for where it crosses through the photo gate, we want to measure the speed at the center of this pendulum bob. And the reason is our conservation of energy equations, the speed that it will tell us is the speed at what we call the center of mass of the object, which we'll explain more in detail in a couple months. But for now, for a pretty symmetrical object of uniform density, it's going to be smack in the middle. That's the point that we care about measuring the speed at. So we're making sure that that is the point that crosses through the photo gate.